Continuing lesson 5 with the second part and final part of this lesson, we are going to try to find all of the zeros in a polynomial function. The goal here is, again, knowing that the zeros are reflective of the roots. And so if we know the zeros, we know the factors. And if we know the factors, we can use division to find additional factors. If we can reduce a polynomial function to a quadratic, then we can solve the quadratic using all of those methods that we learned about last time. Obviously, or not last time, last semester. Obviously, if we aren't able to find the rational zeros by graphing or by factoring, then that means that there are irrational or imaginary answers, and we will have to resort to using the quadratic formula. So we'll review that a little bit, or completing the square, which we won't review a little bit, but if you want to use that, let me know, and then we'll practice that in class. So just remember how to find zeros using the grapher. When we have a function, we can graph that function in the grapher, and we can calculate where those zeros are. So in the y equals menu, we can type in our function, and once we have our function typed in, we can use the calculate menu. Second trace gives you second calculate, and we can look for the zeros at specific locations. Sometimes those zeros are really easy to find. We can see them in the table. Other times, when they are irrational numbers, we will have to calculate those. So again, second calculate the zero, and it's going to ask for a left and right boundary. So for this one that's right up here, we know that it is somewhere between 1 and 3. So I'm going to pick 1 as my left boundary. I am going to pick 3 as my right boundary, and then I'm going to guess. You can either press enter or you can actually guess 2 is in the middle. And it tells you, oh, 2 is the 0. You can also see that in the table, that 2 is a 0. But right here between 4 and 5, it goes from a positive 0.2 on the y to a negative 1.5. So we will have to calculate that 0. And we know it's somewhere between 4 and 6, and we're going to guess 5. And it tells us that it's at 4 and 1/6 is where that 0 is. So we know it's at 4 and 1/6, which means that we could write the linear factors of that polynomial, because for both of those have rational zeros. So practice finding the zeros using your grapher, either by calculating the zeros, the rational zeros, or by consulting your table of values. All right, so we are going to, again, review, like we've reviewed finding the zeros in our grapher. We're going to find our solutions using the quadratic formula. Again, our goal is always to be able to identify what is A, what is B, and what is C. If this is not factorable, then that means that in order to solve the equation, we will need to use the quadratic formula, or we'll need to use completing the square. We're going to focus on the quadratic formula here. I strongly recommend that you rewrite your quadratic formula out every time that you use it. If you do this, two things will happen. One, it won't be a hassle to write it because you'll just write it, right? You'll have the habit and you'll have the knowledge of what it is, so that regurgitating it, writing it on paper, isn't a challenge for you. If it's a hassle for you to write it, it's because you don't know the formula well enough, all right? And so don't let that spirit in you that doesn't want to do work, don't let it win, all right? Instead, write that formula out so that, one, repetition helps with recitation. If you're able to repeat it, then you'll be able to recite it. The opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. We're going to let our calculator do some of that work, but other work there we can do using our head. 2 squared is 4. 4 times 1 times 8 is going to give us negative 32, and then 2 times 1 gives us 2. So give us negative 2 plus or minus the square root of negative 28, all over 2. And here we can see that our radical component is going to give us an imaginary output, but it can also be simplified. So in this case, we have negative 2 plus or minus. This is 4 times 7, and then of course we have the negative, so the square root of 4 is going to give us 2. It leaves a 7 inside and then a 2 on the bottom. Now this we can simplify. If we split it up into two fractions, we've got this fraction plus or minus that fraction. And you can see that there's a common factor of 2 in both the numerator and denominator of both of those fractions. And so this is our solution. All right, so that's review. That's stuff that you've done before. If you need to watch more on that, go ahead and reference our videos from the last semester and see if that will be useful to you. Now, to connect that quadratic formula to the work that we're doing here, what I want for us to be able to do is find all of the zeros of these polynomial functions. And so we're going to do well to make sure that we type these functions into our graphers so that we can identify the real rational zeros of these polynomial functions. If we can tell where the real rational zeros are, then we can divide out those linear factors in our synthetic division. So for the first one, we have this picture. And whoops, let's see if you can see that. And in that picture, we can kind of tell that x equals 2 looks like a 0. I'm going to confirm that in the table. Oh, at x equals 2, we do have that 0. So if x equals 2 is a 0, then that means that x minus 2 is a factor. All right? If x minus 2 is a factor, then we can either use long division to divide by x minus 2, or we can use our synthetic division with this value, all right, with this a value of 2, to figure out what our quotient is when I divide out that linear factor x minus 2. All right, so I'm going to do that work right here to make sure that we can show that our resulting quadratic is x squared plus 3x plus 3. This is not factorable for our other factor, but we will need to use our quadratic formula. So we're going to rewrite our quadratic formula. I know that you're annoyed by that at times, but I promise you, if you have the good habit of doing it, then that is a mark of a good student. That is the mark of someone who is going to be successful on their algebra exam. So, the opposite of b plus or minus the square root of b squared minus 4 times a times c. There's a, b, and c. All right, so a, b, and c, all over 2 times a. And let's do some of that work. Let's find out what we get here. Negative 3 plus or minus the square root of, we've got 9 minus 12, all over 2, which gives us negative 3 plus or minus the square root of negative 3 over 2. So that means that x is equal to negative 3 plus or minus I square root of 3 over 2. This represents 2 of our solutions. This represents the third solution. Now, one thing I want you to be aware of is there should be 3 zeros because it's a degree 3 polynomial. There's 1, and then negative 3 minus I squared root of 3 over 2, and then negative 3 plus I squared root of 3 over 2. Those are the other 2 zeros in that situation. Let's go ahead and give this one a shot. Again, so from the graph, we should be able to tell that x is equal to what? Well, let's go ahead and graph that. When we do, we find out that x is equal to, what's it going to be? Is that positive 3? Let's confirm it. Whoops. Let's confirm it in the table. When x is positive 3, y is equal to 0. Hooray. So from the graph, x is equal to 3 is one of our zeros. We are going to do that whole process of synthetic division and then the quadratic formula. So go ahead and pause the video and do that. Pause the video. Don't copy off me. See if you can get the same result that I do. And this way you don't have to listen to me talk. Sorry for my handwriting. You know it's bad, but if you can do the math, then you don't need to copy what I'm writing. All right, I am going to interject here. We have, again, no remainder. That's a 0 in some cultures. I know my handwriting's bad. But here's where these parentheses matter, because the opposite of negative 2 is going to give us positive 2. Negative 2 squared is going to give us positive 4. All right? And that is going to make, we need to make sure that we have a positive 4 and then subtract the 24. All right, because that's going to give us 2 plus or minus the square root of negative 20 all over 4. 2 plus or minus 2i radical 5 all over 4. If you're having trouble simplifying those radicals, then obviously we need to practice that. All right, come see me. I got lots of practice for you. Here we have a common factor of 2 on top and bottom, so this gives us 1 plus or minus I squared of 5 over 2. This is the other 2 zeros. There's 1, 2, 3 zeros, and so this is all of the zeros for that polynomial. So really, my guess is that this part is going to be really easy for us, and then this part is going to be challenging, and again, appropriately challenging for us, right? We did the quadratic formula back in chapter 10, lesson 7 of Algebra 1. Maybe it was lesson 8, it's one of those two. But you did that in Algebra 1, but on this side, we're dealing with radicals that are going to need to be simplified. And so we're having to use a lot of that Algebra 1, chapter, what would it be? Chapter 11, where we're simplifying square roots. And of course, the Algebra 2 work that we did last semester, where we had imaginary roots. Sometimes we might have irrational roots, and we'll just have to handle that as well. It'll come in strides as we do that simplifying of our square roots. We might find that we have irrational, not just imaginary zeros along the way. So on this one, you are going to do this, you do, and I'm going to do letter C here. So this one, what's interesting about it is that we're going to find that this is a degree 4 polynomial. So if I just have one rational zero, then that means I've got to find 3. And that's not going to work very well because we can't use the quadratic formula in that case. But what I can do here is when I have x to the 4th plus 5x squared minus 36, is I have this graph. And in this graph, we're going to see that there are 2 real zeros, all right? So my table, I should be able to see that that's negative 2 and positive 2. So let's take a look in the table. Yes, at negative 2, I get a 0. At positive 2, I get a 0. So I know by the graph, I know that x equals negative 2 and x equals positive 2. X equals 2 and negative 2. These are 2 of our 4 answers. But what this means is that I have to do synthetic division twice. So I'm going to take my 1x to the 4th, my 0x cubes, my 5x squares, my 0x's, and my negative 36. And we're going to do synthetic division with the negative 2. And then here is what is going to be awkward. After we do that, and again, that happens sometimes where we do this work and then all of a sudden we're a little bit like, wait, what happened? What do I do next? There's our remainder of 0. I'm going to take our new polynomial. I'm not going to write the x cubed minus 2x squared plus 9x minus 18. I'm not going to write that because I don't care about that polynomial. I need to use positive 2 now. I use negative 2, now I'm going to use positive 2. You could switch the order, it would work out just fine. And we are going to do synthetic division again, but with this value, all right? It's going to give us now 18, that makes 0. So now I'm left with x squared plus 9. Now, x squared plus 9 equals 0, solving that equation, we can get by without using the quadratic formula. You can use the quadratic formula. Yes, it'll work just fine. But here, it'd be a good one to solve this by saying x squared is equal to negative 9, which means that x is equal to the positive negative square root of negative 9, which means that x is equal to positive negative 3i. So we have positive and negative 2, positive and negative 3i. For all 4, 1, 2, positive, negative, 3, 4 of our answers. I want for you to do this one. You are going to find 2 rational zeros and you're going to divide them out and you're going to be left with a quadratic. And then see if you can solve that quadratic using our methods from last semester, how we solve quadratics. On that one for letter D, after you do your synthetic division of the 2 zeros you see in the graph, you should have the result of x squared minus 3x minus 1. Again, that's not going to be factorable, so you'll want to use the quadratic formula on letter D. All right, here I took a shortcut. Forgive me for taking shortcuts. I'm going to do letter E, and I'm going to want you to do letter F. Here, let us take this monstrosity, and let's see if we can calculate what those zeros are. Now, this is a degree 5 polynomial, okay? So a degree 5 polynomial means that we are going to have 5 zeros, and this is going to get a little ugly, all right? We've got lots going on here, and we want to make sure that we do a good job of typing correctly. I know that that sounds crazy. We want to type correctly into the calculator so that we can see where these zeros are, all right? And so for me, I am finding 3 zeros in the graph, all right? I have one at positive, you can't see it very well, positive 6, positive 2, and negative 1. So if I look at my graph, I should be able to see that there's negative 1, where are you, buddy? There you go, positive 2, and positive 6. And I can confirm those in the table, or I can calculate those values. If it's at a decimal value, like a 1.5, we're gonna wanna use the calculator to do that for us. So I've got x equals negative 1, positive 2, and positive 6. So now I've got to do synthetic division 3 times to get it down to an x squared, and then I can use my quadratic formula. So this one's kind of a monster, and we're going to do our best with it. I'm going to start and work left to right. I hope that that's okay with you. Feel free to go in a different order than me if you want to try this one on your own. Obviously, these numbers are getting a little crazy, so I'm going to have to reference the calculator maybe a little bit here. This is going to give me negative, 1, which adds to negative 8, which gives me positive 8, which gives me 37, which gives me negative 37, which is negative 200, which gives me positive 200. I get 300, negative 300, and of course, I better have a remainder of 0. Folks, if you get to the end of one of these iterations of synthetic division and you don't have 0, then either you don't have the right factor or you did not do synthetic division correctly. And I know that's frustrating when that happens, all right? So I get it, I'm aware. We're gonna take this polynomial and now we're gonna use x is 2, all right? And again, we should get a remainder of 0 here. We better. Let's see what happens. Copy that, I get 2. I add that to get negative 6. I multiply this to get negative 12. This adds to 25. I multiply those, I get 50. That is negative 150. I double that, I get negative 300. Oh, and my remainder is 0. Hooray! So I did that well. Sometimes I do good job. Sometimes I embarrass myself on here. Over here, again, we're doing these right here. Copy down the 1, multiply by 6. I get a 0. That makes 0. I get 25. I multiply by 6. I get 150. That adds to be 0. So I'm left with x squared and 25. Oh, Mr. Hibbett keeps getting the easy ones. So x squared plus 25. X squared plus 25 will equal 0 when x squared equals negative 25 and x is the positive negative square root of negative 25. So x is positive negative 5i. So I've got 1, 2, 3, 4, 5 zeros. I've got all of my answers, and that should work here. I could do the quadratic formula here. It would just end up being a lot of work, and I don't like to do a lot of work, just like you. And so what I want for you to do for letter F here is I want for you to use your grapher. If you do not have a grapher at home, then you can go to desmos.com and you can use the grapher app to find the zeros, and you should be able to see them in the grapher. In fact, you know what? Since I'm a nice guy, I'm going to go ahead and type that in right here. If you have your grapher and you don't want to wait for me to type this in, then you should be good. Let's see, x to the third minus 159. All right, and then here you can see what your 3 rational real zeros are for that function. And I will let you handle that, divide those out as needed. And by the end of that, you should be able to solve polynomial equations, right? Basically what we're doing here is when I'm finding those zeros, right? I'm finding those zeros. That means that if I have an equation, this thing equals 0, then that means that the x values that make the output 0 are the solutions to that equation. That's the whole point of this unit, is to make sure that we can connect the graphs to the factors, to the zeros, to the roots, to the solutions to the equations, all right? So this is all connected to one another, and we're using a lot of skills to do it and to do it well.